In this video, we're going to answer some beginner-level C# interview questions. I would expect any C# developer, regardless of skill level, to be able to answer each of these questions quite easily. So if you have an interview coming up, it's time to brush up. Let's go. C# is a modern, object-oriented programming language designed by Microsoft. It was originally intended to be used to create various application types using Microsoft's .NET framework. Nowadays, though, you see it used more and more outside of the .NET world, like in Unity for game development. Some of the advantages of using C# over other programming languages, in my opinion, are its simplicity, its strong typing, its built-in garbage collection, its scalability, its integration with the .NET framework, and its extensive library support. And as I mentioned before, it's used quite a bit outside of the .NET framework, so you learning it will not be a sunk cost. The main difference between value types and reference types are where they are stored at in memory. Value types store data directly in memory, and a couple of examples of value types are integers, floats, decimals, while reference types store a reference to the data in memory. And some examples of reference types are usually more complex types like objects and strings. Namespaces are a way to organize and group related classes and other types in your code. They are used strategically in larger projects to help avoid naming conflicts and provide better organization and clarity. Variables are declared using an optional access modifier, then the data type, then the variable name, and they can be initialized at the same time using the assignment operator or the equal signs. For example, private is the access modifier, int is the data type, age is the variable name, and 25 is the initial value. Or you can simply do something like string first name with no value assigned, and the access modifier here is defaulted to private. The double equal sign operator is used to compare the value of two variables, while the equals method is used to compare the contents of two objects for equality. The using keyword has two possible uses. First, it can be used to import namespaces. It can also be used for disposing of resources automatically after use, such as closing files or database connections. The for each loop is used to iterate over elements in arrays or collections, and the for loop is a more general purpose loop for iterating over a range of values or executing code a specific number of times. Exceptions in C# are handled using try-catch blocks or try-catch finally blocks. And as a quick bonus, finally blocks are always executed whether or not the catch block is executed. These access modifiers control the visibility of classes, methods, and other members in C#. Public is accessible from anywhere, including outside of your library. Private is accessible only within the declaring class. Protected is accessible within the declaring class and any subclasses that inherit from it. So if you have a protected method in a vehicle class and a car class inherits the vehicle class, the car class has access to the protected method in vehicle. And internal is accessible only within the same assembly. The static keyword is used to declare members like variables, methods, or properties that belong to the type itself rather than to instances of the type. So it allows you to access the member without creating an instance of the type. Inheritance in C# is done using the colon symbol followed by the name of the base class. Here's a quick example. I have a class named Customer Logic, and it implements the iCustomerLogic interface. C# doesn't support multiple inheritance, but if I wanted the Customer Logic class to also inherit a concrete class like base logic, I can add that because the interface is implemented, not inherited. I can also add more interfaces to be implemented. As long as the concrete class comes first, C# will allow you to implement any number of interfaces. And here's your friendly reminder to like and subscribe. We post new videos often for software developers, software engineers, and software architects. Thanks. Polymorphism allows objects of different types to be treated as objects of a common base type. There are two different types of polymorphism, dynamic and static. We'll start with dynamic. I have a class named animal with a single virtual method named makeSound. Then I have a dog class that inherits animal, and the dog class overrides the virtual makeSound method and barks. And I have a cat class that overrides makeSound to meow. Next, I'm creating a new instance of animal and calling its makeSound method, a new instance of dog and calling its makeSound method, and a new instance of cat and calling its makeSound method. Then I'm creating a list of animals and adding base animal, dog, and cat to that list and then looping over them and calling each makeSound method. When you run it, you can see each individual make its sound and then the list being printed out. Even though the list is of animals, polymorphism allows each animal to call its own makeSound method. Next is static polymorphism. There are also two types of static polymorphism, method overloading and operator overloading. Method overloading is pretty common. I have two different add methods, one that takes 2 arguments and one that takes 3. Operator overloading, though, is much less common. I haven't had to do it in quite a while. Still, interviews are filled with questions that nobody cares about, so here it is. I have a point3D class, and it has 3 integer properties, x, y, and z. Do you see the plus operator on line 36? I'm overloading that operator so that when it's called, I'm returning a new point3D object and adding the x's of a and b together, the y's of a and b together, and the z's of a and b together. Finally, when we run it, you can see 3 different point3Ds print on the screen, but pay attention to line 38 in the editor. The plus operator is being used to create that total sum point3D object, and the x, y's, and z's are added together. Abstract classes can contain both abstract and non-abstract members, while interfaces can only contain method signatures and properties. A class can inherit from only one abstract class, but can implement multiple interfaces, and we just saw a demo of this. The virtual keyword is used to indicate that a method in a base class can be overridden in derived classes. The override keyword is used to provide a new implementation of a virtual method in the derived class, and you may recall that you also saw a demo of this earlier. A delegate is a type that represents references to methods with a particular parameter list and return type. A good delegate example are callback methods. Any method that matches both the return type and the parameter list, or as we usually refer to them, the method signature, can serve as a delegate. An event is a mechanism for communication between objects. To handle events, define methods that match the signature of the event delegate, and then subscribe to the event with the plus equals operator. You can also unsubscribe with the minus equals operator. Structs are value types, which are again stored on the stack. Structs are typically used for lightweight objects that have value semantics. And classes are reference types that are stored on the heap. Arrays are fixed length collections, while lists have a flexible size. Both can be accessed with an index to get a specific element. They both can be iterated over with loops, and both can be worked with using LINQ or language integrated query. LINQ is a set of features that extend C# with query capabilities. It allows querying data from various sources using a syntax that's somewhat similar to SQL. LINQ tends to be a black box for new developers, so I wanted to show a few things quickly in a demo. Here we have a class named Sport with two properties, name and year created. In my constructor up here in the LINQ demo class, I'm creating and adding 6 different sports to the list of sports on line 12. The first demo is pretty simple. I'm creating a new list of sports from the original list and I named it Ball Sports. And in that new list, I'm adding all the sports in our original list that have the word ball in their name. This is done with the where extension method. The content inside of the parentheses after the where is called a lambda expression. The S variable is used to represent each sport in the list as it is looped over. Any LINQ query returns an I queryable by default, but at the end of the line, I'm casting it to the list. Then I'm looping over the ball sports list and printing out the name of the sport. This should return us 3 elements: baseball, basketball, and football. And it does. The next demo is using the single extension method to extract a single sport named golf so I can access the year on the sport and print it out. And there it is. For the last demo, I'm reordering the list by name so it will be sorted. And that works as well. Excellent. If you're confused right now, you're right. I said that LINQ uses a syntax similar to SQL, but all of these are just using extension methods. Most of what you can do in LINQ queries, you can do with the extension methods, and where possible, you really should use the extension methods. For many operations, the extension methods they're just easier. They're easier to read and they're easier to write. But if you want to do joins or more advanced stuff, you'll want to move on and use actual LINQ queries. If I rewrite the first ball sports query as an actual query, I want a list of sports, of course, and I will name this one ball sports 2. From is just like the SQL from, but the order and syntax is a little bit different. Here you can think of B as an alias for sports in the list, and it's just like the S in the extension method version. Next, where is also like the SQL where, and I want to filter the sports by name.contains ball. Finally, we select B. Finally, we wrap the query with parens and cast it to a list. Now, this query is exactly like the extension method above. You could literally spend hours working on LINQ, but this video is already pretty long. If you enjoyed this video, check out this one for ASP.NET Core interview questions. You might enjoy it if you're hoping to do web development. Until next time, keep coding.